Awesome. So hello, everybody. Just a moment to talk about the environment that we're using here with live viewers on Cloud9. Obviously, it helps us massively from not having to kind of set up or change your local environment, change your current version of Python, Windows, Mac, et cetera, For those maybe watching later on a recording, as has already kind of been stated, the Bridgecrew.aws workshop.io workshop is there 24/7. And just as there are prerequisite steps for creating a Cloud9 environment, there's also steps for using your own AWS account should you wish. So if you are coming to this at a later date, or you want to go back to it in a week's time or show colleagues and things, all the resources needed to recreate what we're going to do today will be available. But some manual setup may be required, and we have the luxury of not needing that with the Cloud9 kind of shared cloud IDE, which is awesome. So all we're going to do here now is just kind of append to our base setup. So you'll see I have a Cloud9 environment, and just like you will at this time, I have installed the Python VM, I've installed JQ, and we've got to the end of that dependencies section for the AWS setup. And I'm going to just go through the Bridgecrew setup now. So if you haven't already created a Bridgecrew cloud account, you'll need to go to bridgecrew.cloud, and you can sign up for free using a number of sign up methods, or just directly via an email, and we will email you a temporary password. So I've already done that, and I've logged in, and I have my new Bridgecrew account ready for this AWS Dev Day. So I'm ready with that. So go and create one of those if you need to. And the other prerequisite for accounts is a GitHub account. So if you don't have a github.com account, that will also be useful as well. Again, if there's some parts you cannot do through corporate policy or not, by all means, listen and kind of either get involved later or kind of go back through the material at your own pace. So all we're going to do now is install a couple of tools into our Cloud9 environment. So the first one, again, I have done 3 of these dev days now, and I still forget there's a little copy button there. I always highlight and copy. But the first thing we're going to do is install Chekhov. And so to do that, we can literally just go to our Cloud9 environment, which I'm going to move over here. And because we're already in our new Python environment, we can just do pip install Chekhov, and that's nice and easy. While that installs, we're also going to install a new open source CLI called Your that we'll cover a little later on, which helps with tagging and kind of matching cloud infrastructure to the infrastructure as code objects in Git. But we'll get that installed now, just so that it's ready as well. So we'll see we have Chekhov installed already. We can do Chekhov -- version. And that will just let us know that, yep, we've got Chekhov installed. And now we'll quickly copy and paste that second command to go and install Your as well. And yeah, there we have Your ready to use as well. If this is moving too quick for everyone, we are going to go through a little bit of context and just a little bit of talking. So there's plenty of time to open this yourselves at bridgecrew.aws workshop.io and kind of catch up. So no worries at this point. The last thing we're going to need is a Bridgecrew API token, and we're going to use this for various items. So you can follow the GIF here, GIF, pick your favorite. And we're just going to save that onto the terminal for future reference. So you can either save it in a notepad, or you can put it into an environment variable. So I'm going to get the API token from in the Bridgecrew account you've just created, integrations API token. Please don't use mine. It won't make much sense because you won't see anything in your Bridgecrew dashboard. So these are all ephemeral accounts anyway. And what we can then do is we can just go back to Cloud9. And what I'm going to do is create a new file. And I'm just going to not only store it there, but I'm also going to export BC API key and paste it in there on my terminal as well. So that in future, if I have a command, I can do, things like this instead of going and finding that. And that will be available to us when we run commands in future. So not necessary. If you want to copy and paste it from a notepad and things, that's absolutely fine too. And that brings us to the end of the setup. And so we can jump right into the exciting stuff. And the fixing of infrastructure as code issues, the scanning for problems with our CloudFormation and our Terraform and our Kubernetes manifests and all that good stuff. But first of all, why are we doing this? And again, this context is available on the workshop. But what is the point of, we talk about DevSecOps. We already have DevOps. Like, what are we really trying to achieve here? And quite simply, the idea of DevOps is we're taking, a single set of responsibility from both the operations team maintaining the infrastructure, maintaining maybe the CI/CD pipelines, and the developers writing the application code, the features, the customer requests. And we're making sure that there's a shared responsibility model for those teams to work together right from the start. And the way we generally do that is through automation. And through DevOps, we enable a pipeline so that a developer knows that when he makes a change to Git and commits that change and does a Git push, things are going to happen to test his code, validate his code, make sure it's fit for production, and then also do that production deployment in a hands-off way or with a minimal kind of manual approval chain where it's just kind of a tick box for someone giving it a looks good to me, maybe through GitHub issues or maybe through any other pipeline of choice. And that basically allows us to go from potentially manually validating a release once a month, once every 6 months, to the point that people might be doing 10, 20 deployments a day to production as a team. The problem with that, well, there's two issues with that. And the first one is by automating everything to that level, what we have to use is infrastructure as code. Now, this in itself is a good thing. Having our infrastructure be repeatable, having it be tracked in Git, just like our application code, allows us to know when changes happen, allows us to roll back to a known good configuration. All the things we couldn't do if we were manually building bits of cloud infrastructure through, for example, the AWS UI. Good for exploring, good for playing around, but realistically, you need to know that you can roll back and know exactly what's running in your infrastructure and recreate that infrastructure in new environments if need be. And so with that infrastructure as code comes effectively more code. And just like we want to secure our application code against against vulnerabilities, maybe a dodgy library, obvious SQL injection, things like that, for which we have kind of application security code scanners, we also want to make sure we're doing the same with infrastructure as code, security code, because while it's not necessarily a CVE, while we don't think of it as vulnerabilities, these kind of insecure defaults that you might have in a given piece of Terraform or CloudFormation can actually give the hackers their first step into your infrastructure. And I think a recent report said about 70% of like the first actions that turned into a full-on breach were because of a misconfiguration rather than a CVE or an application vulnerability itself. So, it is important that we put that sec into our DevOps pipelines and that we're doing the same with our infrastructure as we're doing with our application code. And so if you're new to infrastructure as code in general, the infrastructure as code type we'll be looking at in this workshop mainly is CloudFormation. So CloudFormation allows us to describe AWS objects as code. And as you can see here, this is a piece of CloudFormation for creating an Amazon S3 bucket. We can specify all kinds of properties that you might otherwise specify when manually creating an S3 bucket using the AWS console. And this just allows us to, as I said, store our infrastructure in a repeatable way in our Git repo, just like we would application code. So what we will do here is look at some infrastructure as code, and we'll look at how we can automate and protect ourselves against those kind of misconfigurations and insecure defaults from getting into our production applications. So we've already covered prerequisites. So without further ado, unless there's any questions immediately, let's jump in. So the first thing we're going to do is we're going to clone a sample repository of infrastructure as code. And obviously, we're not going to expect you to bring one of your production code bases to a workshop like this. So for the sake of kind of learning and exploring, we've created a number of projects that we call the GOAT projects. So for those that use Terraform, we have TerraGoat. And for those that are interested in CloudFormation, we have CFN Goat. Now, these are public projects, and what they basically do is we've created a load of CloudFormation as if this was the piece of infrastructure as code that was going to deploy your application or your production environment, but we've purposely made it as riddled with misconfigurations and insecure defaults and vulnerabilities as possible. So we use this as a really good resource for kind of learning about infrastructure as code misconfigurations and the kind of security issues they can cause. So the first thing we're going to do is we're going to take a copy of the CFN Goat repo onto our local Cloud9 environment. I told you I always copy rather than click the button. So we can run that. And then if we change directory into that new Git repo, do a Git status to see that we're in the Git repo. And then what we have in here, you can actually go and explore it through the Cloud9 IDE here. But you'll see we have a load of CloudFormation. And this CloudFormation has EC2 instances, Kubernetes instances. We're not going to deploy it because it's absolutely riddled with security misconfigurations. We'll be deploying a small subset of this with less serious issues later on. But this allows us to show how easily we can kind of protect ourselves before this CloudFormation even becomes a real object in AWS by running infrastructure as code security scanners like Chekhov. So what we will do is run a Chekhov scan locally against our infrastructure as code. So within the terminal, you'll see that we have a file called CFN Goat. We also have a separate piece of CloudFormation for a EKS cluster, but CFN Goat has enough vulnerabilities for us to be worried about for now. So what we can do here is we can run this Chekhov command because we've already installed Chekhov. And the only thing we will need to do is whatever you called your Bridgecrew API key variable, you'll need to set that there. Or if you just saved it to a file, that is where you will copy and paste that into BC API key. Okay. And what we'll do here is run this. And just do me a favor, if your command says repo rather than repo ID, just do me a favor and refresh this page because you should have repo ID and branch for this command. So just make sure before you run this command, otherwise you might get an error. So that's looking a lot better. And what we can do is we can quickly kick off a Chekhov scan against the CFN Goat CloudFormation. And what this is immediately going to do is it's going to go and find anything in that file that looks like any of the infrastructure as code types that Chekhov supports. Now we support scanning CloudFormation, Terraform, ARM templates, Kubernetes, Helm, Docker files, kind of you name it. If it's infrastructure as code, we'll probably have some checks for it. And once it realizes that this is CloudFormation, it's going to run all the CloudFormation checks built into Chekhov against this, and it's going to provide us some recommendations of issues. So what you can see is it's going to spit out a load of different items that are against compliance, that are against common industry practices. And we take a lot of these policies from kind of CIS guidelines, other compliance like PCI NSS, and we consolidate those, both ourselves, Bridgecrew security team, and the community around Chekhov, into these useful policy IDs where we can see a description of the problem, and we can see which resource within our infrastructure as code. So this is an EC2 resource, and then which line and which file of the scanned repo it's in. And then for each one of these policies that fails, we also provide some guidance. So immediately, let's say someone's running Chekhov that isn't necessarily a security advocate within the team. We provide guidance for each one of these issues to just give a bit more context to that developer as to what the problem is, why this is an issue, and what can be done about it to fix that. So as you can see, because it's CFNGO, there are obviously a lot of issues. We have different output formats for Chekhov. You can ask it to output in JSON so that you can do some post-processing should you wish on all this data. We can also do it in a streamline mode where we're not outputting the actual piece of the file. So you just get a nice streamlined list of the checks that have failed. And then we also give a bad exit code for the Chekhov command if there's any failures. So you can imagine, and we'll cover a little bit later, putting this into CI/CD becomes very, very easy. So we've already seen this output, and that at the very core of itself, if you take one thing away from today, running Chekhov against your CloudFormation or your Terraform is going to allow you to find issues before that code goes into production. That's going to allow you to kind of protect yourself and realize that maybe there are some insecure defaults that you need to look at. So Chekhov comes built in with a load of policies, and you can actually list those out with Chekhov --list. And by all means, go and explore kind of the other things you can do with Chekhov with --help. And you can see that you will be able to tell it to only, check for certain checks, not produce the guide URLs, change the output type, give the compact output with none of the code and all that. So that's the tip of the iceberg. And as I said, what we can do is we can change the checks, we can skip checks, we can do all that kind of stuff. But the reason we pass Chekhov the API key is where Chekhov suddenly gets really powerful in a team environment, or when you're not just running this as a lone developer or a lone operations member of staff. You can run Chekhov without the API key, and it will do a completely local scan. Let me just show you that quickly. If we do the same without that, we'll get the same local results from Chekhov once it's parsed the CloudFormation, and it will give us that same kind of local display output. But the power of running Chekhov as we have done with that API key is, you'll notice at the end of the output, we got a URL directly into our Bridgecrew account. He says, let me make sure I'm logged into the right account. Here we go. And if we go into code reviews, maybe I used the wrong API key. Give me a sec. Let me just check I used the correct API key there. The demo gods clearly giving me a little bit of a test this evening, but that's absolutely fine. What we'll do is we'll go ahead and just rerun that. And so what this is basically doing when you run it with an API key is every time you do a Chekhov check, it's going to pass the results and pass that information into the Bridgecrew dashboard. And that's a really good place to consolidate and view all of these issues at once. You can then start doing things like prioritizing issues by severity, which is very hard to do on the CLI. And also, if you're running this in a CI/CD pipeline, which we'll see in a moment, a single team can then get a snapshot of all the different CI runs, whether there's more or less issues, and just start to really kind of use that information more intelligently than just single time outputs on the CLI. So once this finishes running, we will get a new link. By the way, yeah, please do use the chat for any questions. And I see Yaniv has appeared. I think we have a question. Hey, Yaniv.
Yeah, just a short question here about checkoffs, taking a step back. So checkoff, if we can run through this again, it supports Terraform, we said, right?
Right.
CloudFormation, which we are looking at also today, Kubernetes, um, Docker, Docker file or a Docker image, or how would you define that exactly?
Yeah, so both actually, we've supported scanning Docker files. So, hey, you shouldn't be creating root containers. There needs to be a user parameter in there. But actually through the API integration with Bridgecrew, we can also now scan Docker images for application level vulnerabilities within the images from the same tool.
Okay. Did I miss anything else there as
Um,
well for checkoff?
Yeah, Kubernetes manifests, Helm charts, where we basically template out the Helm chart based on the defaults in the chart and then run the same Kubernetes scans against those manifests. So yeah, you can let Chekhov loose on a good number of infrastructure as code sources.
Nice. Is there any particular version that it would support with Terraform? When we talk about Terraform specifically, I think there was an announcement for a new release a few weeks ago as well. Is all of that supported by Chekhov as well?
Yeah, absolutely. A few of the really, really old versions of Terraform might struggle. We're basically using the same kind of parser that Terraform uses with some, we maintain a public fork of that. So yeah, it's the same kind of parser for HCL that HashiCorp themselves use. So yeah, it should support anything that they currently support.
Nice.
Cool. Thanks for the question.
Yeah.
So while we're waiting for that, let's go and look in here. And what we will see is, close that trial down. What we will see is that because we have run that with the API integration, our Bridgecrew dashboard has started filling up. Obviously, this was a brand new account. We had nothing in it. And what we can now see is we're starting to see those same Chekhov issues, but in a much more kind of useful way where we can now start to filter them. So we can filter based on critical and high only. We can filter them based on specific benchmarks, specific categories, for example. And if we have multiple sources, which we will do by the end of this workshop, we can even say, actually, we care about a specific, we only care about a specific source. So for example, which repo, which Git repo, which AWS account, and things like that as we start to build this up. So if we see here, we've only searched for high and critical severities. And for each policy, we then get a list of the items that have failed rather than having one output per item per policy. So just a much nicer way of kind of drilling down and visualizing, especially across large IAC code bases like CFN Goat, we can see exactly what's going on. In the code review section as well, we usually get a list of the individual reviews. I don't know why that's not refreshing, but let me just very quickly show you that here in another account. So in code reviews, you can see for each time you run Chekhov anywhere with that API integration, you also get a breakdown of just that run that you can kind of click in and see a point of time snapshot of what the situation was. So incidents gives you all of your current issues that need resolving across all your sources. But we also provide more developer-centric views, such as the individual runs of Chekhov like this, and also a projects view, where if we're integrating Git repos directly, which we'll cover in a little while, you can directly drill down to, if you're a developer that only cares about one particular repo, you can drill down to that particular repo and see its current status as well, along with a load of other developer related info. We're jumping around a little bit here, so let's get back to the workshop. And again, all of this is available to go through at your own pace and retry some things if you need to. So what we've done there is we've seen that everything you run with the API key in Chekhov gets attached into Bridgecrew, and that's just a much nicer way of finding, filtering, and sorting. Now, That's all well and good, but obviously what we're not expecting developers to do is we're not expecting them to add another manual command on their workstations to their kind of daily development lifecycle. We don't want you to have to do git add and then check off scan and before you push anything. What we really want to do is automate this just like the rest of our pipeline so that we have everything done for us. And so all this data not only fills up the Bridgecrew dashboards, but also allows us to fail a CI/CD pipeline and stop the process of putting code into production if we find some of these issues. So with that said, let's jump into module 5 and look at automation. So we're going to look at 2 styles of automation here. We're going to look at AWS code build and AWS code pipeline, and then also GitHub Actions. So the first thing we're going to need to do is at this point, we are going to want you as workshop attendees to be able to make changes to the infrastructure as code so that it triggers new pipeline builds just like you would with your own code repos. So at this point, we need to each create a fork of the CFNGoat repository in GitHub. So if you go to section 5.1 and click on this link to open CFNGoat, and then what I need you to do is just click on the fork button in the top right-hand side. And I've already got CFNGoat forked, but you'll be asked to choose where you want to fork that to, and you want to fork that to your own personal GitHub username. As you can see, mine is MetaHertz, and I have a fork here for CFNGoat. So go ahead and do that, and that will only take a few seconds for GitHub to fork that. And then as seen by mine, you will have your own fork of CFN. And now what we're going to do is we're going to set up an AWS code build in our, awesome AWS Event Engine account so that we can see how we automate this from Git all the way through to potentially production. So what we're going to do here is, first of all, go into Bridgecrew, and we're going to look at the vast array of integrations that we have in Bridgecrew for Bridgecrew to automate things and, for us to not have to manually run that checkout command to get things into the incidents page. We can use these integrations to have Bridgecrew automatically do things and automatically integrate with things on our behalf. So what we're going to look at first is we're going to go down to continuous integration, and we're going to find AWS code build, and we're going to click add subscription. Now, what that is going to give us is, first of all, a command to run. And so we can just run that directly in our Cloud9 environment. And what that's basically going to do is it's going to store the Bridgecrew API key as a secure parameter in AWS so that other AWS products and services can securely access that value when needed. And the thing that's going to need that is obviously going to be our CI/CD pipeline that we're about to build. So usually you'd have had to configure your AWS credentials for your AWS account on your local machine. But because we're using the Cloud9 IDE, they're already configured for us because the AWS account knows who we've logged in as. So you can run AWS CLI accounts to your heart content. So that should just run, and you should get a standard version 1 response back. And then just moving some things around for cleanliness here. And then the next thing we're going to need from that integrations page is we're going to need to take a copy of this. So this is basically a section of a code build pipeline that Bridgecrew is providing for us that we're going to be able to place into our pipeline when we finish configuring it. So just as I did with the previous API key, I'm going to create a new file here in our IDE, and I'm just going to save that for later on. Just leave that open and ready. So at this point, we're going to need to create a new code build project, and we're going to call it Bridgecrew tutorial. And if we click on the hyperlink to code build, that should take us directly to the section of code build we need, he says. Bad link, no worries. So in your AWS environment, let's close down that page. If you need a second, obviously we don't want to close Cloud9, just as an FYI. So what I'm going to do is I'm just going to copy this URL into a new tab and then get rid of the Cloud9 section just to get directly to the AWS console. And then you can see we're still signed in with our temporary Event Engine account. And then what we can do is we can search just like we did for Cloud9, and we can go to code build. Okay, and once we're here, we can click on create build project. And then basically, if you want to change the names, just remember that you've changed the names. We're sticking with these because they're consistent throughout the whole workshop. So I'm going to follow the naming convention in the workshop, but you can do what you need to do. And description is completely optional. And what we're going to do is we're going to follow this through. And code build can take its code repo, take the code it's actioning on from anywhere, including GitHub. So what we'll do is we'll say, yeah, this needs to be code we're building and creating a pipeline from GitHub. And at this point, it will ask us to connect our GitHub account. So we can follow this process through. It will redirect us to GitHub to ask for permission. Demo gods really not being happy with me today, are they? Let's try that again, shall we? Interesting. Let's go reload that page and see if we have an issue with the page loading there. Copy that again. Choose GitHub. We're connecting using OAuth. Connect to GitHub. There we go. Don't know what was having a problem there, but once that's connected to GitHub, that should allow us to retrieve all of our GitHub repos automatically. So once we're in this scenario where it says you are connected to GitHub using OAuth, now for those of you that haven't used code build and code pipeline before, it might redirect you to the github.com webpage and ask you to click authorize, and screenshots of what that looks like are in the notes. So you'll get something like this just to confirm that you want to connect to GitHub. So go ahead and click authorize on that. And then we are back in a scenario where we can select repository in my GitHub account. And at this point, it should let us see all of our GitHub repositories, and we can pick CFNGO. Now, I have access to a couple of CFNGO organizations, but the one I want is the personal one that we just forked. So I'll pick Megahertz CFNGO, and we can carry on. So at this point, again, it's all here if you need to catch up or you want to follow this on later. So we're choosing repository in our GitHub account, and then we're heading on to configure the rest of the pipeline. So down here, we'll pick managed image for environment. We'll let it create a new service role. And for operating system, we will click Amazon Linux 2, I believe. Oh, Ubuntu. There we go. We'll pick standard runtimes. And for image, I believe we'll pick 4.0 because that's what we've tested the workshop with. So just in case there's any changes in that kind of default Ubuntu image, let's go for that. Leave the rest as its default. And then when we get down to build spec, this is where what we copied and pasted comes into play. Now, for every kind of CI/CD system that I can think of, you can have a file within your Git repo that stores what you want the pipeline to do, the instructions for the pipeline, as a build spec file, for example, in the repo. But to make things easy for us, you can also, just for the sake of the workshop, directly tell the pipeline through this insert build commands what we want the pipeline to do. So at this point, we'll click insert build commands. We'll click switch to editor. We'll get rid of all the defaults in there, and we will copy in the snippet of code build pipeline that Bridgecrew gave us. And this is a really simple code build pipeline that allows us to add Bridgecrew. Okay, so we'll paste that in here, just like that. And then we will click create build project. And I believe while that's building, Yaniv, did we have a question?
Yeah, we got a nice question here. Maybe you will answer it also in the latter part of the workshop, but the question is, do we have to run Chekhov scans in build pipelines, or they can be triggered whenever a pull request is submitted? I know it might be possible via webhooks, but is it supported out of the box? We got this nice question in the chat. So
that is a great question. So one thing that's really cool about running Chekhov in your pipeline is that's one place where we can, like, a CI/CD pipeline is a great place to be able to block things going to production, like that final point before production happens. But 100%, like, it's not the only place you want to be checking for these policies. The way we can do automated pull request scanning isn't directly through Chekhov. As has been mentioned in the question, there needs to be something listening to receive webhooks and then to automatically respond to those webhooks. And through different Bridgecrew integrations, we can do that. So for example, and this is covered a bit later, but I just think it's a really exciting thing to jump into. If we do, for example, a GitHub or a GitLab integration, this does a couple of things. This not only give me a sec. This not only automatically then scans the current repo without having to run Chekhov, without having to run any CI/CD pipelines. Bridgecrew will go and kind of check out a copy of your repo itself and put anything it finds into the incidents page under a new source. So for example, here you will see new Git repos, even if you've never run Chekhov, even if you've not got anywhere to run Chekhov like a pipeline, the GitHub and GitLab integrations will automatically go and scan your code directly in those repos. And a side effect of that integration, a side effect of that integration is it then automatically does PR scanning on chosen repos as well. So the answer, long-winded, is yes. I'm showing this here and the flow just because, yeah, it's super interesting. So if I go and find CFN goat, and let's say also TerraGoat, which I have forks both for in my Git repo, and click done. What we're going to see is we have a successful webhook integration with GitHub. And at this point now, and I will show it a bit later on in the workshop, not only will we start to see policies that violate, issues that we find appearing in incidents, but you'll also find Bridgecrew annotating every future pull request you do. And I actually have an example of it here, but we'll see it live a little bit later in the workshop. So what it looks like is this. It's almost like Bridgecrew becomes like your virtual security advocate on your team. And so for every new pull request that comes in, you'll get immediate annotations like this, very similar to kind of Chekhov's output, as you'll see, this resource, we don't believe you should accept this pull request. the severity is low. These are the lines that are the problem. And once again, we have a link to the, extra information and context as well. Yeah, great question.
Than's. That is
No worries.
very impressive how you actually set that up during answering the question. So thank you.
Third time lucky, eh? We strive to improve every one of these workshops. But yeah, we've got the integration running, but we'll see it live with a PR hopefully in a little moment. So back to our code build environment. And what we now have is we have a successful code build pipeline created. And so we can actually just start the build by clicking start build. And what this is going to do is, pardon me, it's going to check out the latest commit of the master branch of your, or main branch of your CFN Go fork. And it's then going to run Chekhov against that fork. And, you will get information directly in the logs, just like you would if you ran Chekhov manually. The one issue and why this run is going to fail, it's not a problem, we can rerun it again, is once we've done all this and we've built our project, because of how AWS permissions are kind of denied by default, it doesn't just share keys across products. When we ran that command to save our Bridgecrew API key into AWS, the code build pipeline we've just built has absolutely no permissions by default to access that AWS secret key from System Manager. So what we need to do is we need to go and find the role that the code build pipeline runs under and give it access to our System Manager private key. It's only something we need to do once as soon as we build a new pipeline and never again. And those of you familiar with AWS will be familiar with kind of smallest permissions necessary for a given role. So we can do that by clicking the AWS IAM dashboard link. That will open us directly into the console. And we can go and find the role we care about. And we can do that by just copying the name. If you called your pipeline something else, this will be different. But I should be able to find that role fairly easily. And what we'll see is this by default has no permissions other than things related to code pipeline. So we can add a new inline policy to this role. And at this point, what we're going to tell it is we want access to Systems Manager, and we need the get parameters and get parameter actions. So we can go in here. We want Systems Manager. And we want, and you can see as you typing, it's narrowing down to make it easy to choose. So get parameter and get parameters action. And now we need to specify what parameter within System Manager secrets we need. Obviously, we do not want to give our CI/CD pipeline in a busy AWS environment, potentially, 1,000 secrets that System Manager is storing. We only want to give it access to the secret it needs to prevent overexposure. Now, there's two ways we can do that. We can either fill in these sections and type our region, our account, and the name of the API key, or because we've already stored it in Systems Manager, we can actually run this command back on our terminal and query the parameter. And as part of the output of that query, we will get our ARN for that direct resource in Amazon. And what we can do is we can say specific resource, add ARN, and we can just paste that. Oh, pardon me. And we can just paste that in here, and you'll see it fills all those out for us. So we can click add. So what we're saying is get parameter and get parameters for that one specific secret. And we're giving that to the role that the pipeline runs under. Review policy, give it a name. Add Bridgecrew code build API. create policy, and then we can see it's there. So what we'll see is if we go and look at this build, it failed. And it failed because, as I said, we didn't have access to the secret we needed for the pipeline to run. Whereas if we now retry that build with the new policy, we'll see what we need to see. Just confirming everyone can still see and hear my screen because my Mac is making strange noises.
It looks great.
Awesome. Thanks, Yaniv. Okay, so with that running, let's just reset where we are within the workshop. So we've made sure that we have access to the API key we need. And as I've said, we've kind of skipped ahead a little bit and automatically triggered manually triggered the build by clicking retry build. And what we're going to see is this is doing everything for us that we'd have to do locally. It's installing Chekhov. It's then running Chekhov with the API key to integrate with our AWS, with our Bridgecrew environment. And it will then provide us a kind of nice output within the code build environment itself, but also give us that constant feed of information into Bridgecrew. And what we're going to start seeing, based on the question that Yaniv just fielded for us, actually, is Bridgecrew is really designed to give you a single location for all points along kind of the pipeline, from the developer writing the code to the objects actually being created in AWS in production. And so what we'll start seeing in here is, let's refresh this page. Now we've integrated, for example, GitHub, which we did earlier. If we go and have a look at the sources, we no longer just see, hang on, let me make sure I'm on the right. Make sure I'm on the right account. AWS June 21. Yeah, perfect. We won't just see the violations that were created by the Chekhov runs. We'll automatically start seeing as well the violations directly coming in from that GitHub integration and scanning those repos. So we can see here, if we turn all these sources off and we just turn the CFN goat one on, we can filter based on just the issues that we're getting from that Bridgecrew reaching out and directly scanning that GitHub repo. So for example, we'll see a CFN goat issue here for policies do not allow credentials exposure. But then if we also say we want to see what we're getting from our Chekhov scan as well, we can see that we're seeing that violation twice, once in our Git repo, once triggered by Chekhov running as part of our CI/CD pipeline. And then when we get to the point where we integrate AWS runtime so that we can actually see the objects which have made it into a real AWS account, if that problem does exist in production, you will effectively be able to see how far a policy violation got. Is it just in Git? Is it deployed in AWS? And then equally, when you fix that issue, you'll see all of those disappear. So there's nothing worse than fixing an issue in AWS, but then because it's not fixed in Git, the next time someone deploys, it undoes that manual fix. And the way Bridgecrew has been designed is so you can see every point along that pipeline to make sure that that issue has truly gone by measuring the same policies at all those different steps. So with that said, let's have a look at our code build. And you'll see the output from code build is exactly what you'd expect. We can see that it's checked out our code as part of the CI/CD pipeline. It's giving us the same output we would expect if we ran Chekhov manually. And then right at the end, it will also give us a URL, which we can either click on, he says, or paste, or we could go into the code reviews tab and see that automatically appear in here. So there we go. We can see that we have CFN goat running, and we can see that run kind of annotated nicely for us here as well. And that URL will pretty much take us to the same place. There we go. So that's really useful for people looking into the Bridgecrew dashboard, maybe looking across multiple repos, but also directly in code build. If we go to report groups and click here, we'll also see that as part of, let's find it. He says, referring to his own notes. Yeah, as part of report groups, we should also see, let's have a look, is it this one? Yeah, sorry, I just haven't clicked deep enough. We've also told Chekhov to output in a JUnit XML format as part of the CI/CD pipeline. So we actually get, even within the AWS environment at a glance, we get a much kind of nicer web-based view of the Chekhov output rather than having to kind of scroll through like you would on a CLI. And you can see the repo, the names, and kind of an at-a-glance view of passing versus failing resources. So the next section that we would go and do is code pipeline. Now, I obviously manually clicked trigger this run. Code pipeline basically allows that to automatically trigger as part of a commit happening in that repo. And so effectively, you can think of code pipeline as receiving a webhook from Git, be it GitHub, GitLab, an AWS Git repo, and is the thing that then goes and tells one or more code build processes what to do based on the actions it's receiving. So maybe it's a pull request, maybe it's a commit into master or main. Yes, so that's what code pipeline is going to do. And it's basically going to allow us to trigger automatically what we've just seen. It's going to allow us to trigger, get that review, get that JUnit XML, and also see the information automatically pushed into Bridgecrew. In the interest of time, I'm not going to cover that bit, but as I said, the dev environment that you are using is available for 24 hours after this session. So please, by all means, follow those steps through. And then if you make changes to your own CFN Goat repo, you will see that automatically triggering and you'll get those same results. And as you'll see on the pipeline results page, what we've just kind of said, we've already covered by digging into the output. So for those of you using AWS and CloudFormation and your CI/CD pipeline is more GitHub Actions than AWS code build, we also have the ability to directly create a GitHub Actions, just like we had that kind of copy and paste template for code build. We also provide the same for GitHub Actions. So if we go into integrations, which, as I'm sure you're guessing from now, is where most things start when integrating things with Bridgecrew, we can go in here, we can go and find GitHub Actions instead of AWS code build. And what we have here is add a subscription. And in very much the same way, it's telling you what to do for GitHub Actions. So we can add our API key to GitHub secrets so that the CI/CD pipeline knows how to access that API key. And as part of an existing GitHub action, we can add a step to automatically run Bridgecrew. And the result of that will be the same. We'll still get the CI/CD pipeline failing if we have a policy violation, and we'll still get those issues showing up as a new data source in the Bridgecrew platform and the URL at the end of each so that we can see each of the CI/CD runs in the Bridgecrew platform as well. And so this is all well and good, but great. I've found a load of issues in my infrastructure as code repo. What do I do about them? And so one of the things we can do is automatically fix and provide information on how to fix some of these issues. So once we have investigated the violations in Bridgecrew, which we've already kind of clicked around and had a look at doing, As we saw, we can filter based on benchmarks, based on sources of information, and based on severity to kind of work out what we need to focus on first. The next thing we can do is start seeing that in some cases, and I'll do this live, and by all means follow along with me because you should have some good data in your environment now. So if we go and find, for example, some violations with some S3 buckets, here we go. We have a lot of buckets, and you can see multiple sources for this information coming through. But if we have a look for these ones that have come directly from our CI/CD pipeline, we can see that, let's say, bucket.logs bucket, we can see this one just says, it's telling us that we're violating a policy that we need to have restrict bucket enable. However, if we just filter based on our CFN Go Git integration, and we click on the logs bucket, we can see that it's actually providing us an automatic remediation. It's saying, hey, the way to solve this problem is actually to add these lines to your CloudFormation. Now, the reason it's only showing us that on certain types of resources is obviously CI/CD is a great place to stop builds from becoming vulnerable infrastructure in production, but it's not a good place to edit code. Because if you edit code in CI/CD, that's ephemeral. It will just get replaced with the vulnerable code next time you run that pipeline, because you're just changing effectively a read-only point-in-time copy. The right place to make changes in infrastructure as code is Git. Git is our source of truth, and that ties more into a regular developer's pipeline. Any changes they expect to see as a pull request, or as at very least a commit by a trusted developer with a new commit ID into that Git repo. And so by integrating pipelines to allow us to prevent things getting to production, but also integrating source control so that we have access to that, initial source of truth, be it GitHub, be it Bitbucket, be it, any Git repo we support. What we can do is we can start automatically generating fixes. And so, as I said, if I find an S3 violation again, and we have a look at it, it's going to say, yep, this is how you fix that. And if we tick that box and click fix, it will ask us if we want to raise a pull request to that repo. And if we hit fix and go to our CFN goat fork, you'll find we have a new pull request from Bridgecrew. And this is suggesting the change that we just saw. Oh, my apologies. Think I jumped over a bit too quickly. So this is the new one that's just come in. It was open because we clicked that button 14 seconds ago. And if we look at files changed, it's the exact property that we were showing in that diff in the Bridgecrew platform. And so that is how we expect to see changes made. We expect them to be permanent in Git, and we expect to be able to look at that pull request and go, yeah, we understand why it's been raised. We're providing detail and guideline links there so that developers can go, yeah, okay, we understand why we need to fix that and push that into our master or our production branch. So you wouldn't have been able to click fix unless you had done the, as I said, we jumped around a little bit there, unless you had followed me along and done the integration of GitHub. So that you have this green GitHub integration, you wouldn't have been able to click fix and raise that pull request. But if you want to go ahead and do that now, you'll actually see we're perfectly on point for the GitHub integration section here, where we're going to authorize Bridgecrew to be able to do these things like automatically scan our repos and then automatically raise pull request fixes. And so what we've just seen there is 6.3. We've kind of gone through, we've seen the same violations show up through multiple sources, but we can fix them on Git-based sources because that's where we can create a pull request. And in the example here, I fixed the financials bucket rather than the, what did I choose? The logs bucket, but it's very similar. We see the diff, and then we can create that pull request fix. So if there are a couple of questions, that'd be great. I could answer those while, if anyone wants to kind of go through and do this Git integration here, that would be awesome. Yaniv, have we got anything, or should we carry on?
Yeah, we got one question that I tried to answer in the chat, but we can try and answer it here as well. Maybe I misinterpreted the question. And the question was, can Chekhov Bridgecrew assist with formulating the minimal permissions needed to deploy a Terraform setup? And because AWS IAM provides the checking after the fact through monitoring the system or the IAM user. So the way I understood this question and what I think is that the question is kind of, the broader aspect of this is, can we use Bridgecrew to actually create our least privileges architecture that we deploy in AWS? Can we do that beforehand? Or instead of, and it's the whole DevSecOps thing. Instead of having things working after the fact, can we shift left and make sure that we enforce least privileges before we deploy something into our AWS environment?
Sure.
And I think it goes back a little bit to the introduction, but I have some link that I'll paste here in the chat about how to do it, and I'll also let you kind of answer that question.
Yeah, absolutely. So as I'm sure your link, Yaniv, probably is going to highlight, so the issue with IAM policies is until you run the code that either can or cannot access AWS resources, you don't necessarily know what that application code is going to need in terms of AWS APIs. And so it's very hard to constrain a policy having never run the code against the cloud. But again, that's not very shift left. So some things that Bridgecrew can help with there. We have a built-in feature called IAM Insights, which I'm sure we will paste the blog to that IAM Insights kind of blog post when we announce that feature into the chat, so you can follow up on that. What IAM Insights does is it looks for really common patterns of kind of never acceptable IAM policies. So let's say you have something, a policy that has a star in it, or you have something that is going to allow another role to assume that role or that policy when it shouldn't do. By default, if we're just looking at your Git, we're just looking at your Terraform, we can do that. We can then do even more with kind of other features combined in the platform. So for example, if you're using Terraform and Terraform generates a plan where it actually queries the cloud provider on what currently exists before making changes. As part of your CI pipeline, Chekhov and Bridgecrew can actually scan that plan as well and get even more insights as to what your IAM configurations look like, and maybe provide you some more suggestions for reducing the exposure. And then finally, and we're going to show it in a moment, the kind of final piece of putting all this together with Bridgecrew is the runtime integration. Now, kind of to your point, it's already in runtime, but once we are in runtime, Bridgecrew can use that to provide even more insights as well, because we can actually see what is running and not. A plug for a piece of open source software that I really like and I think is going the right direction of this is called IAM Live. And I'm just going to try and find it. And IAM Live basically allows you to use the AWS client side monitoring to work out what applications are reaching out to in terms of an AWS set of APIs. And so if, for example, you were running full integration tests locally or in a dev environment, something like I Am Live might actually be able to work out exactly which API endpoints those applications are hitting, and you could use that to create yourself a set of minimal access policies. In terms of hackers trying to add pull requests to give stars and things that are absolutely not necessary, and people being able to assume different roles, Bridgecrew will catch all of that by default, even just in the CFN or the Terragoat. But yeah, in terms of the minutiae of knowing what is needed, I Am Live is the only thing I can think of that is before the fact. We have another open source project called Air IAM, which actually will pull down all of your current IAM configuration and give you recommendations on, okay, well, this role has never had the, for example, EC2 API accessed, even though it has permission, maybe get rid of that. This role hasn't been accessed for 400 days, maybe delete that. And all those kind of suggestions for right sizing your IAM. It also allows you to turn that IAM configuration from your AWS environment into Terraform. So at that point, you can actually continue to maintain your IAM configuration from Terraform if you're in a brownfield environment. So hopefully between those and Yaniv's answer as well, that's given some food for thought. But yeah, IAM policy management is like a whole workshop on its own, I think, which, hey, Yaniv, might be food for thought. That might be a fun thing to do.
Yeah, I'm down always for IAM. I think we got one more here. Taylor, I see you open your video. Do you want to go?
Sure. I think this one is a leading question for our new projects page, but the question was, why can't Bridgecrew submit multiple changes in a single PR?
It can. I was just being really lazy on the demo. Yeah, it absolutely can. So if we find some problems, of which in CFN Goat there are many, and again, we kind of search for S3. So let's say, in fact, here's a really cool way of doing it. Let's show a feature we've not shown before. So let's go into the projects view, where we can drill down to the individual Git repos we care about as a developer. And so in here, we can see, all of the issues across just this repo rather than the incidents view where we see everything. And so we can see we have an issue here with operations bucket. So let's click fix on that. And you'll see I have one issue of a total of 56 allowed in a single PR. So then I can go through and I can get really, really trigger happy with all of the issues that are fixable off the bat. I'll do one more down here. And then as you see, if we click submit on that, that's now a 4-issue PR that it's going to hit, and it's going to fix all 4 of those repos in one. Cool. So he says, or it should. I don't know why that failed. But yes, that is a fully supported feature. And with that, I hope that anyone that wanted to kind of go ahead and do that integration with the GitHub account has succeeded to get through 6.2 and 6.3. And that leaves us with a couple of things, and we've kind of touched on those. By the way, really liking the participation. Thanks for the questions. I know we're jumping around a little bit, but hopefully it's kind of more interesting to hear like what people's pain points are, and real questions coming in for what people are trying to achieve with infrastructure as code security. So the last thing again is another integration, and it's kind of that last piece of the puzzle. What if we're in a brownfield environment? What if there are resources long running in our AWS accounts that were there before we started using infrastructure as code? Or what if we just want to make sure that someone hasn't reconfigured our CI pipeline without our knowledge, and actually Chekhov is now not blocking, and we're starting to see real issues getting through our pipeline and into production. And for that, pardon me, we can use our AWS integration. So by default, we recommend the read-only integration, because this is a super, super minimal set of permissions needed in our AWS account to just give Bridgecrew the metadata it needs to go and check that account against our policies. We can also do live fixes in AWS by using the read write, and suddenly that fix button on issues will appear for some runtime issues as well as some Git integrations. However, obviously that is a choice for you to make as a company, because it does require Bridgecrew being able to write directly to your AWS account. And also there is an argument that if you're following infrastructure as code practices, you should be making changes via PR and CI pipeline rather than directly into production. But enough use cases have been raised that we do support that as well. So again, following the AWS runtime in 6.4, super simple step here is we go into our Bridgecrew account, we go to the AWS read-only cloud provider integration, we click add account, and we click launch stack. And what this does is then links us over to CloudFormation within whatever AWS account we're currently logged into. And what you can see here is it's going to fill in a CloudFormation stack for us. And by creating stack, that's going to create the role and the minimal required pipeline between the Bridgecrew platform and AWS. So it'll take a moment or two to just run that CloudFormation. We can either watch it and keep hitting refresh, like it's an Amazon Prime delivery that we really want to arrive, or we can go and look at something else. So once that stack's created, what we'll see is the AWS account ID shows up in the account itself. And we start to see things directly from runtime, and we can filter down on those, and just the same as we do for anything else. And like I said, we support IAM insights, which don't necessarily get highlighted in Chekhov, but if you do the integration directly with runtime, we can pull more information from there and start doing IAM right sizing as a diff, just like you saw in the kind of Git examples. We can actually go, for example, here and say this IAM role has way too many permissions, and here's what we recommend. We recommend you delete this section of this IAM role in your runtime environment. And obviously, if you did allow the read-write integration, we could automatically fix that for you in the same kind of tick box click fix way to right size that IAM policy. Let's go and have a look how this is getting on. It says creation's complete there. And so if we go and look at our Bridgecrew tab, that could still be processing because it could still be doing its initial scan of the environment. But at a certain point, hey guy, at a certain point that will go green, and we'll see that that integration is complete. And then we'll start to see those items appear in our filter page down here. So we can see that it's already appeared. So that's our CI/CD pipeline, because it's the name of the code build pipeline with our account number. These are all direct, either Chekhov runs from the CLI or GitHub integrations. And we can see this one is our actual GitHub, sorry, my apologies, AWS runtime environment. And we can start seeing that even just kind of some default configuration in the environment, it's recommending changes, for example, ensuring log metric filters and alarm exists for config configuration changes and things like that, that we can click on and get more information. Cool. So in the interest of time, obviously more and more things will appear in there as that integration continues to scan the environment. Gone green now, but I can actually show that in a busier AWS account where there's actually a lot more going on than just these brand new event engine accounts. So if we go into our incidents page here, and we look at just this AWS account here, this one here, which is there's a lot more going on. You can see that already we have, we're seeing that things have gone through into runtime directly in that AWS account that it's suggesting we do something about. And if I had the read-write integration, we'd be able to fix some of these as well. We can also just filter by IAM insights in runtime environments, which is super useful. So for example, here we find a role that isn't used but should be detached. We find that there's users that may have not been used that we should delete because they're not being used, but they have admin privileges and things like that. And then should you want in your test environment to try this after the webinar, again, fixes are super simple. When you try and fix something that can be fixed in runtime and you don't have the remediation integration set up, the read-write integration, it will tell you when you try and do a fix. And the way to do that, again, is just in the integration page with the remediation stack. And in the same way as the previous one, you just click launch. And this is going to create another CloudFormation stack. But this asks you for a lot more permissions because obviously it needs more access to your AWS account. And then with the last kind of 20 minutes, I want to obviously leave some time for Q&A. And I also want to talk about something fairly new in terms of open source that I think a lot of our customers and a lot of the people we talk to in the AWS community are quite excited about. And this is about kind of providing more of a bridge between what is running in our runtime environment and how we kind of trace that back to which piece of infrastructure as code was created based on that, and vice versa. And so tagging and tracing, everyone has a tagging and tracing strategy, whether you are adding tags manually, whether you are doing something in your CI/CD pipeline. But we've created a new open source project called Your to answer kind of the why of code to cloud. So far in this workshop, we've seen how kind of we provide automation to detect, to block, to scan pull requests, to fix issues with automated pull requests, to make sure that those issues aren't in your AWS account to begin with. But what it doesn't really answer is like, why was that resource misconfigured in the first place? Which teams might have been responsible, or which team do we need to contact to work out why something is like it is? Maybe even which teams will be impacted by this remediation. If we do remediate an issue, which teams have had touch of this piece of infrastructure that they might be relying on, and when did that configuration first appear in the infrastructure as code base? And so that's exactly what Your tries to achieve. So we've already installed the Your CLI. We did that at the beginning. So we can do everything we're going to do here from our, let me just find my, there we go, Cloud9 environment. And so what we can do here is we can use Your to automatically tag some infrastructure as code resources. And we can then show the value of Your having automatically tagged those as part of our day-to-day environment, especially when we're chasing down security issues. And these work perfectly hand in hand, because some of the things that Bridgecrew finds, Your is going to help you find the owners, in kind of larger non-workshop environments. It's super useful to have this kind of go between the code and the real world AWS environment. Now, because CFNGO is so full of vulnerabilities and kind of, I'm pretty sure Yaniv would give me a slap on the wrist based on the shared security responsibility model of AWS. We're not going to use CFNGO to kind of deploy, because it would be deploying a lot of very, very vulnerable pieces of infrastructure into these environments. What instead we're going to do is switch over to people that enjoy Terraform. As I said, CFN Goat is one infrastructure as code repo. We have TerraGoat, which is another for learning. And I've created for this demo something called Deployable Goat, which is a very small subset of really low severity issues, which won't put the AWS account at risk. And we're going to do a live deployment of those into our AWS account. So what we can do first is we can come out of our CFN Goat repo just for cleanliness, and we can clone the Deployable Goat repo. And you'll see in Deployable Goat right now, it's a very, very simple under the AWS directory. There's basically just a bit of Terraform with a few kind of low severity issue buckets. This one has public read, but not public write, but has nothing in it. This one isn't encrypted, doesn't have access logs and versioning, but again, nothing in it. So things that are not really going to put our environment at risk, even if running as a, on a non-Cloud9 environment and a non-Event Engine environment, should I say. So it's a very, very simple piece of Terraform. And what we can do with it here is use your to add tags to that Terraform, and then we'll see how it looks afterwards. So if we just go ahead and give your no introduction to start with, and we just tell your to, recursively go and tag any infrastructure as code resources it can find within that directory. We can see what yours done here is it said, okay, for each piece of infrastructure as code I've discovered in those files, I'm going to add all of these tags. And it gives you an output and a summary up here. But if we now go and look at S3 again, you can see our Terraform looks very different. So in Terraform's own language, and the same with CloudFormation, it's actually queried the very Git metadata within this local directory. Yours realized it's a Git repo. And so it's taken information about which org, which repo, who has modified, who last modified this particular piece of infrastructure as code. And for each individual items, for each individual S3 bucket, KMS cluster, VPC, it's also given a your trace, a unique ID that we can use once this item gets deployed. And so with those, we can effectively go ahead and deploy that Terraform, and we will. But first of all, I'm going to do what any dev would do after making changes, which is commit these your tags. Doesn't matter whether we do that or not, because we can't push this back to my repo anyway, but just as an example workflow. And what's really interesting just before we deploy is if I try and tag those resources again, your doesn't see its own tags as a change, which is the behavior we want, because we don't want the person tagging all the resources to suddenly then have been the last modified person of the resources. So your can ignore its own tag block. And so you can safely run your as many times on a given repo or a given code base as you want. And it won't constantly change the tags. It won't change the unique IDs. It will tell you that there's no resources to trace and it's not needed to update any of them. So let's put these tagged resources into our AWS environment together so that we can actually see the benefits of having these tagged traces. So if I do a Terraform init, and I'll need to be in the AWS subdirectory here. If I do a Terraform init, and then do a Terraform plan, again, because we're in the Cloud9 IDE, Terraform's automatically going to find the AWS credentials, connect to our AWS workshop environment, and it's going to say, yeah, we're going to create these 3 S3 buckets. And with that, for the first time today, we're actually going to do a Terraform apply. And we're going to go and create some resources and hit yes. We're going to go create some resources live in our AWS environment. And so once they are created, we should probably talk about making that, again, like we did with Chekhov, not a manual thing. Your is designed to run automatically in the CI/CD pipeline and run with permissions to basically then allow itself to commit those tags back at the start of your CI/CD pipeline, so that these tags, these who was the last person to modify this bit of CloudFormation or this bit of Terraform, just automatically happen. So you don't even have to think about your, it's just there for traceability benefits that we'll cover in just a moment after a question via Yaniv. Hey, Yaniv.
Yeah, we got a few questions here. Very cool with your. I love what you did there with that project specifically. And we have a question here which is worth discussing, I think. Thank you for that question, Ajaya, and it's related to SCPs. So they are using in their organization SCP. SCP, for those who don't know, it's service control policies in AWS, where you can define basically a set of services in an organization level, and then assign them to some IAM role so they can use that service. Very high level what I just said. There's a whole policy evaluation logic, and everything is there in order to kind of enforce that whole concept of staying least privileged. So
Okay.
if I use SCPs, the question is, if I use SCPs, do I still need to use your? Does it make sense if I use your in terms of a use case here, if I have SCP for my organization? I think the answer is yes, by the way, because SCPs, as I mentioned, they define more of these set of services that you can access in your company. But I don't know if you have a take on this as well.
Yeah, I think you're probably in a position to answer that more authoritatively than me, Yaniv, because I've not played with SCPs particularly. But yeah, your really isn't about access specifically. It's more about, and we'll see this once those resources have deployed, it's more about just, if you put this in your pipeline, it almost complements everything else we're doing, because security, what we're doing in this workshop is showing how we can automatically detect and remediate issues, but not all issues are immediately remediatable. You might need to go and find out who will be impacted by that resource changing. You might need to work out which teams have historically changed that piece of infrastructure. The person whose name might be on the whiteboard responsible for that service might have left 4 months ago. And so suddenly you're like, well, who is responsible for this service now? Yours designed to kind of, very lightweight by adding these tags in your CI/CD pipeline. They're not something you care about until you need them. And they're just designed to really help you identify blocks of code in GitHub to running AWS resources and vice versa. And in fact, let's kind of have a look at that right now. So in the same way we have examples for GitHub Actions for Chekhov, you can see here we have your GitHub Actions marketplace item. And effectively what this is going to do is this is just going to run your and automatically recommit those your tags without having to run your and then git add and then git push like I was simulating in Cloud9. And then what it basically means is you end up with something like this. For every commit, author changes happen automatically as a separate commit. So again, still sticking with the whole proper GitHub source of truth. There's no secret squashed commits. We can see that your has made those changes, and it will update individual blocks of code. For example, when I make a change and the last person was Nimrod, suddenly the last person to make a change was me. The git commit changes, the your trace doesn't, because it's still the same piece of infrastructure, but suddenly I am appended onto the git modifiers as well. So I know in total who has edited that piece of infrastructure through its life cycle. So let's see what that looks like in runtime. So the first thing we can do is we can easily find resources in the cloud based on Git information. And there's a few ways we can do that. In our Bridgecrew environment, we have a resource explorer, which if you enable the runtime integration, allows you to basically quite powerfully query all the resources across your environments. So if I say I'm interested in AWS environments, I can say I'm specifically interested in a demo environment, and then suddenly we can see all the resources with whatever tags they might have. And if I then try and say, this might not have updated quick enough, but yeah, within a few minutes of those resources existing, we'll be able to search based on arbitrary tag or key values here. And so an example of that in an existing environment is if I go into resource inventory, and obviously you guys have this, the Bridgecrew account is a fully featured 14-day trial. For the person asking about the IAM integration, go ahead and try the runtime integration with the demo AWS account or your own AWS account and see what insights it provides. But what we can do here is we can say provider AWS. We can select a specific account we are interested in. And then already you're going to start seeing quite a lot of tagged resources from your. And so if I say, okay, I want to see all the resources that Matt at bridgecrew.io has touched last, and suddenly I can see the 3 buckets that we've just deployed through that Terraform init. So I can immediately search based on person and a few other things. So I can search based on, hang on a minute. If I have a look at those, I can see what items in my AWS account were created based on a given Git commit. So by searching for that Git commit, I could find all the items that a CI run at a given time on a given date created. I can see the modifiers, the fact that Matt is the only person that's touched this piece of infrastructure as code, and all that good stuff. And the other thing I can do the other way around is, oh, and by the way, if you run AWS config, obviously all these searches I'm doing in this resource inventory are also available directly in the AWS config. But let's say we care about the other way around. So we found through Bridgecrew, highlighting problems, we found a resource in our AWS account that we are not happy with. So if we have a look in our S3 account, in our AWS account, and we have a look in our incidents page, and we filter based on our runtime integration, and have a look. Yeah, take a little moment to show up. So like I said, I'll just default to this account. By all means, give it a refresh in a few minutes so that you can kind of see this for yourself in your own environment post-workshop. But what we have is basically an exact mirror of the workshop environment. We're just giving things a little bit longer to finish their scans of the runtime environment because we've only just deployed those resources. So what we can see here is, again, another of Yaniv's event engine accounts, to which I've already deployed your tagged deployable goat resources. So if I search for S3 here, we'll see we have, some policies where restrict public bucket needs enabling, and there are our tagged resources here. Now, okay, that's great. I know I have a problem here. Where did this problem come from? And so these resources here actually allow us either from here, or let's say that we noticed it directly through AWS itself. So let's say in S3, we noticed, crap, that's a publicly available bucket. That's not necessarily a good thing. Who created that? Where did it come from? And what we can do is by looking at the properties again, either directly from a issue we found in Bridgecrew, or from the AWS console itself, we can use this your trace to go to effectively our entire organization and say, you know, I don't know why GitHub hasn't found that in the search, but it's definitely there. I know it's there. So I pushed my tags for this example to example your tags. Obviously, we didn't push those changes. We just deployed with your, but we will be able to see here, and this is definitely in this repo. So I don't know why that is saying that. GitHub, your search isn't working. Because if we go in here and go into S3 and find that exact string, if GitHub was having a good day and its search box was working, you'd be able to, across your entire GitHub organization, just search for that your trace and immediately not have to work out which repo, which infrastructure as code, which software project. All you've done is in your entire AWS org, you've got a bucket that through Bridgecrew or through AWS, you found a problem with, and you can immediately narrow down if it has a tag through your exactly where that resource has come from. So yeah, that's kind of the alternative side to your for the two basic use cases. It's both, you know, easily finding cloud resources based on Git information. So searching for, you know, what was created with this Git commit, what was created by this Git author, and inversely, easily taking cloud resources and answering the, where are they in my Git repo? Where are they in my infrastructure as code repo? So, you know, hopefully just as an aside to everything else, that really complements kind of day two security operations of then finding the why and where for the more complex remediations that maybe aren't just a simple quick fix that might have been in your AWS account since, you know, X amount of time, and it's not just turning a true to a false. And with that, I kind of have left a bit of time for any questions. We've also got the all-important raffle for the headphones. So yeah, Yaniv, Peyton, everyone, any other Q&A?
We got a few thank you here. There's a question here about how does your work with Terraform modules that expose tags? Assumingly, it just looks at the tag property name and auto-injects. What about more complicated setup, like a sort of a more complicated pattern that you can use in Terraform? So how does it work, I guess, is the essence of the question here.
I don't think I fully understand the question. So what we're basically doing is reparsing your Terraform with the HashiCorp HCL2 parser and effectively building up our own object view of each of those so that we can correctly inject the tags. And then the way your is built internally is there's a bunch of pluggable modules, one of which is the Git tagger module that then goes and looks for if it's a Git repo, you know, pull out all these things and add these tags. Your then remembers which tags are related to your so that it doesn't see those as a change. And there's some pretty robust logic to make sure that your ignores its own tags so that we're not constantly saying there's a change every time we're doing tags. I don't know if that quite answers the question, but you know, happy to discuss that if someone wants to reach out to me deeper. I would also say, do check out your.io because we've only just touched the surface of what your can do. There's a custom tagger based on a configuration file where you can actually use some of those existing tags to say, okay, well, if the, for example, Git author is any of these people, add another custom tag that says team is SecEng or team is application one. So you can actually, with a very simple your config file, you start creating your own custom tags, either just, you know, raw text or based off other tags that your has already added. So yeah, there's a really powerful set of kind of flow down logic there where you can create tags based off other tagging plugins. And, you know, we are planning to create a lot more plugins as well for things like cost allocation and things like that. So yeah, by all means, do join the community or come and ask us questions on slack.bridgecrew.io if you kind of want to really jump into the weeds on how you is working.
Awesome. Well, again, thanks everyone for joining. We'll send the recording today. And if you have any other questions, you can respond to that email and we'll get back to you.
Thanks everyone from AWS for joining us and helping out. And as always, thanks Peyton, and thanks everyone for joining.